Hello friends, in today's video we will be discussing the dense vector field type. A dense vector is used when dealing with a vector of numeric values. Dense means that the vector is mostly filled with non-zero values. You should use this field type if there are few or no zero values. Note that dense vectors don't support aggregations or sorting, and storing multi-dimensional vectors is not possible. To retrieve the closest vectors, we use ElasticSearch, which we will cover in a future video. Also, remember that the maximum size for a dense vector is 4096. Now let's look at some examples of how to use the dense vector field type. In the first example, we use the index method to pass the index, document ID, and the document itself. Here the document has two fields, a text field and a dense vector field. As you can see, working with this field type is straightforward. You just pass in the array of values. In the second example, we show that indexing fails because we are trying to store a matrix instead of a vector. This operation is not supported by the dense vector field type. It's important to note that when using the dense vector field type, you must manually define the mapping. ElasticSearch cannot automatically infer the mapping for vectors, as it requires details like the exact number of dimensions in advance. In a previous video in this series, we covered how to set up the mapping. Here is an example that shows the creation of an index with two properties, size length and shape. The size length is defined as a dense vector with 4 dimensions. You can also provide additional parameters to size length, which are available in the documentation. The second field, shape, is defined as a keyword, but this is not important in our case. Before moving to the notebook, please, if you want to read more about the dense vector field type, check out the documentation. Now let's go to VS Code. Open the notebook number 15. If you want to read more about the dense vector field type, click here to go to the documentation. Make sure that ElasticSearch is running and run this cell. Great, so we are connected. Now, as I told you, when creating the index, we need to do the mapping manually. And here I am showing you the same example that we have seen in the slides. Here I have two fields, and size length should be a dense vector with 4 values. So the dimension here is set to 4. After that, when indexing documents, all of them need to have 4 values. You cannot index documents with variant sizes of vectors. That will not work. Okay, let's create the index. And now here I have 2 cases. The first one, which showcases the valid case. This is how you use the dense vector. Here I am trying to index a document. So shape is square and size length, as you can see, contains 4 values. If I run this, here I get successful and it shows me that that document was created. Great. Now let's see the mapping just to verify that it is the correct mapping. And sure enough, you can see that size length is a dense vector. And you can see that the dimension is set to 4. But we have other parameters. This is what I talked about in the slides. For example, here we have similarity, which is set to cosine. This is going to help us retrieve the documents. We have other values. We can, for example, set it to dot product or other metrics. And if you want to know how to use these parameters, please just check the documentation. There you will find everything you can customize about the dense vector field type. The second case, which is the invalid case, this is simple. You can see that here, instead of indexing a document with a vector, I am trying to index a document that contains a matrix. This is not supported, and when I try to run this, it gives me an error. You can see that here it couldn't parse the object. When using dense vector, please just provide a vector and that will work. We arrived at the end of this video. I hope that it was helpful and informative. Please, before leaving, leave a like on this video and subscribe to the channel if you want. See you next time.